Good morning, everyone. In the last session, we discussed about the exception landing here. So today we are going to discuss one of the important concept called multi-threading here. Okay, so this is basically the important concept we are discussing today, and from today onwards, we'll try to work on the multi-threading concepts. And here, what we need to understand basically, by default, Java will support the multi-threading here. Getting the point. So whenever we are having the predefined classes here, the built-in multi-threading support is available. But the problem, whenever you are trying to create the custom example like custom classes, or you want to come up with a custom multi-threading support here. Getting the point. So I want to create explicitly multiple threads here. So what is the way of creating this? So we'll try to understand from today onwards here. Okay, so basically here, what we need to understand here, and here, so whenever the multi-threaded program, it's contain the two or more parts of this particular threads here. So it's nothing but, so two or more than this particular two parts of, it's going to run concurrently here. So for example, I'm having one Java compiler along with the Java compiler. So this is JC I'm trying to write here. So Java compiler, and this is our text editor. Okay, this is our text editor, and here, so I'm going to open MS Paint here. This is our MS Paint. Now if you see, so these three applications we open. So whenever we open this particular three applications here, what happens internally? So each application is going to do the specific performance here. So it's going to do the specific operations here. Whenever it is trying to do the specific operation, what we need basically, we need a separate thread here. Getting the point here, separate thread we need here. So this particular separate thread basically what it will do, it will try to provide the, getting the point, it will try to provide the separate path of execution here. Getting the point, this is important we need to understand here. So now what you need to understand basically here, whenever we are trying to opening, so more than this particular two parts here. So this is the one part here. So this is the another part, and this is the another part. So to want to perform the operations concurrently. Concurrently is nothing but, so simultaneously, so it needs to perform the operation. It's not going to depend. Like here, the Java compiler internally, it is not depending on this particular text editor, and the text editor basically internally, it is not depending on this particular MS Paint here. So each operation is doing differently here. Getting the point. So each operation is doing internally that what we need to understand here, what we need to understand carefully. So whenever we are trying to work on this particular more than these two parts of execution concurrently, here each thread is having separate path of execution. So this particular advantage we are going to get from the multi-threading concepts here. Getting the point. This is important. Now, so you can understand one more example I will provide here. So let's see here, one is another example. So we have a e-commerce application. One item we are having, getting the point, one item. So it's trying to come up with this particular item is going on with some offer related information. Now what they will do, the most of the people, they will try to buy this particular specific item. Okay, now you can see we don't know how many users will try to enter into our application here. Getting the point. So this is important. We need to understand how many users. So we are going to get this particular item to buy this particular item here. So for example, so 6 users are trying to access. Getting the point. 6 users they are trying to access. Whenever they are trying to access this particular information, what we need to understand basically, getting the point. What we need to understand basically here, each user they need to get the specific result. Each user they need to get specific result here. This is important we need to understand here. So whenever they are trying to find out the same result with this particular All the users. How many users we are having? So 6 users we are having right now. If I'm going to pass the same information to the 6 users, so here the business we are going to lose, because one user is going to buy the item, and if the same item information we are going to pass to the other information, now what happens internally? What happens internally? So the same, even though the item is not available, but we need to give the same item to this particular 6 people. But what we need to provide here? So whatever the information we are trying to access, basically this information, this information. So we need to share only one person here. So we cannot share the same information to the multiple people here. So this is the separate path of execution is going to provided by the multi-threading concepts here. Okay. So this is important. We need to understand here. Getting the point. So now, along with this, so it support the virtual modeling operations here. So if you observe carefully, nowadays, what are all the operating system we are developing? All the operating systems are supporting, like all the operating systems are internally implementing the multi-threading concepts here. So why they are implementing the multi-threading concept? Basically, so here we are trying to open the multiple applications at a time. Whenever we are trying to open multiple applications at a time, what we need to understand here? So here basically we are going to share the each application information to the same whatever the applications we are opening. For example, if I'm opening into this particular Java IDE, and if I'm going to open another application with Python IDE. Okay, so Java information we are not going to share with Python, and same the Python related information we are not going to share with this particular Java here. Okay, so this is important. We need to understand here. Getting the point. This is important. We need to understand. So here separate thread is going to execute, and here also separate thread is going to execute here. So these two threads they are not going to communicate each other, because this is the separate path of execution and this is the separate path of execution here. Okay. So this is we need to understand very carefully here. Now what we need to understand basically here, now, what we need to understand basically, whenever they are trying to execute internally, we have a two processor here. First is the thread based and another one is process based. Basically, process based also it's going to run two or more threads two or more parts concurrently. But here the problem, process is basically heavyweight task. Getting the point. Internally, it's going to take heavy weights, the heavy memory allocation is going to take, and whatever the process is going to execute internally, which is going to take more time here. So, which is going to take more time. So, this is we need to understand very carefully here. Getting the point. So, now what we need to understand basically here, what we need to understand basically. So, here whenever we are trying to discuss with this particular thread based, so internally threads are light weighted, process are heavy weighted, and so process can contain the same path of execution whenever we are trying to execute this particular multiple threads here. Getting the point. Whenever the process we are trying to execute, basically what happens internally, we are going to have the same path of execution. But whenever we are trying to execute this particular thread basis here, each thread can contain the separate path of execution. So it's not going to depend on the other threads, or all the threads they are not going to communicate with each other here. This is the one of the important we are going to get from this particular multi-threading concepts here. Okay, so this is we need to understand. Okay, so as I explained, basically it's going to create, it's going to support the built-in multi-threading concept. But whenever we are trying to create the custom classes, how we are going to achieve the multi-threading, and if I want to create a custom threads, getting the point. If I want to create the custom threads, so what is the way of creating this? So we need to understand here. Okay, so as I explained, so this can contain the thread information. Okay, along with this particular thread, so we are going to provide the priority. Okay, along with this particular priority, we are going to have thread group name. Okay, this is important. These are all the three main concepts we are going to discuss. What is the name of the thread information, and what is the priority? Getting the point. Along with this particular priority, we are going to discuss about the thread group name here. Okay, so this is we need to understand very carefully here. So now understand the simple example how we are going to discuss about this particular multi-threading concept here. So multi-threading internally, it's going to work on this particular three concepts here. Okay, so let's run the simple example. And here, so if I want to create a thread, basically, we have two options here. So either we can go for this particular runnable interface. Okay, first one is runnable interface. Second one is thread class here. Okay, first we'll understand the runnable interface, and later we'll move on to this particular thread class. So because thread class can contain some additional methods, and the runnable interface cannot have additional methods. Only one method we are having inside this particular runnable interface, that is called run method. Getting the point? So this is method we are going to override here. So we'll observe here, so which one is the best option to perform to come up with the creating a thread information here. Okay, so first we'll see what is the basic default thread we are going to get. What is the default thread we are going to get here. So once we identify the default thread, we'll try to create the custom threads here. Okay, so let's run the simple example here. And to run this particular simple example, now what I will do, so this is, we already created the package com.facebook.multithreading. Now what I will do here, I'm going to provide, getting the point, here I'm going to provide current thread demo. Getting the point, current thread demo. So inside this particular current thread demo, now what I'm doing is, I'm going to print the name of the current thread. So to print this, basically thread dot current thread. So here I want to understand here, current thread is a static method or instance method. So what you're trying to think basically here, whatever the method I'm calling here, the current thread method is a static method or the instance method. Okay, so basically this is a static method. So why we are explaining it is a static method? Because this is the name of the class. So just now we discussed about the thread class. Okay, so we can create an object with help of this particular thread class and runnable interface. Now what I'm doing here, first I'm trying to find out the default thread here. First I'm trying to find out this particular default threads. Later I will try to create the thread information. So to find out the default thread, is nothing but if I want to find out the which thread is trying to execute this main method. Getting the point? So which thread is executing this particular main method? Now the name of the thread information I'm trying to find out here. So if I want to find out the thread information, what I'm doing is, so we have a one method, something like a current thread. Using this particular current thread, using this particular current thread method, we can get the current thread information here. So this is the current thread information I'm trying to print. Okay. So now you can see whenever I'm trying to run this example here, now observe carefully, this is the current thread information. This is the current thread information. So here, this is the string message we provided here, and this is the toString method. So this is, we already discussed in our previous example, how we can override this toString method here. Okay, so first we'll see how this particular toString method is override inside this particular class. Which class here we need to understand. So what is the reference of this particular current thread? It's contain this particular thread class here. So it contains the thread class information. Now where we can check this particular toString method? Inside this particular thread class here. Okay, so this is important, we need to understand here. Now, so let me go to this particular thread class. So can you see the information? Thread class basically internally is implementing from the runnable interface. Getting the point. So here, what we need to understand here. So as I explained, we can create a thread information with help of this particular runnable interface, and we can create it with help of this particular thread class. But observe carefully, internally this particular thread class is trying to implement from the runnable interface. Okay, so directly you can implement this runnable interface, or you can extend this particular thread class here. So getting the point. This is important, we need to understand. And later, now what I'm doing here, so I'm trying to provide the information about this particular toString here. So whenever I'm trying to provide information about this particular toString here, now observe. Now observe, basically, here what I'm doing here. So now you can see, here I'm trying to print this particular thread. So who is printing? This is the predefined method. Whatever the toString we are trying to see here, this is the predefined method which is available under this particular thread class. Okay, so just we are trying to identify the how this particular toString is implemented. So you can see, so this is the thread, and here we are printing this particular same thread in our console. After this, one array type brace here. Okay, so this is where we'll call it as a bracket here. After bracket, opening the bracket, they are trying to call name of the thread here. Get name. So get name, basically it will try to provide the name of the thread. So the first one, this is the name of the thread. What is the name of the thread currently we are having? Something like main. And after this particular name, we are having comma. So the comma is printing here. And later, what we are doing here? We are trying to print this particular priority here. So we are trying to print this particular priority here. So this is, we need to understand here. This is, we need to understand the priority. So what is the priority we are having right now? 5. After this particular priority, again we are having comma. Getting the point? Again we are having comma here. So later, what we need to understand here, we need to understand regarding this particular group name. So from where this particular group is coming here, so now you can see this is the name of the group. Get thread group. Getting the point? So each thread can contain the thread group information. So the thread group information is printing. If the thread group is not equals to null, so it will print this. Otherwise, only two messages: name of the thread and priority. Name of the thread as well as priority we are printing. But right now, we are getting this particular thread group also. We are getting thread group also. Now, so which condition is satisfied? This particular condition is satisfied, and this is the println message is printed here. Getting the point? This is the particular println message is printed here. Okay, so now you can see the toString method, how it is printing. This is important here. Okay, so if you're not familiar this, now what we can do, whenever you are trying to extend this particular thread class, you can override the toString method, and you can write whatever you're trying to expecting here. Whatever you're trying to expecting here. Okay, so this is the way of printing this particular object information. Now we understand. So let me go back here. Now what you understand here? So which thread is calling by default? This is the main thread. Getting the point? So the main thread will call by default. And now what you understand here? The default thread, it will try to call this particular main method, and whatever we are doing the operation. So earlier, what are all the operation we provided? Now if I'm going to expand our exception related here. Okay, this is our my exception class we created, and whenever this particular example we created, so which thread is executed this? Which thread is executed? Whatever the main thread we are having here, the main thread is executed all the exceptions here. So for whatever the example we discuss here, from the beginning onwards, all the examples are executed by the this particular main thread. Now what I'm doing here, I'm going to create custom thread. Okay, so we'll see how we can create the custom thread. The first information, I want to modify the name of the thread. Getting the point? I want to modify this particular name of the thread. So what is the method we are having? Set a name here. Getting the point? So current thread dot set name. Whenever we are having current thread dot set name, we can provide the message here. So whatever you are trying to expecting here. So something like current thread. So once I provided this particular current thread, now what I will do, again I will print this is out here. Now you can see the differences we'll understand here. So first default we are getting as a main. Now I override with this particular name of the thread here. This is important here. Initially we are getting the main as a thread name. Now what I did here, so I modified to this particular current thread here. So this is the way of overriding the thread name. Otherwise we can provide the name of the this particular thread here. Okay, so this is the name purpose we are going to use to modify the thread name information here. Okay, so now what I'm doing here, I'm going to use one loop here. I'm going to use one loop. So before going to use, so here I'm using the try block, and inside the try block, int I is equals to 0, I less than 5, I plus plus. And here what I'm doing is, so I'm going to print this, I'm going to print I value. Okay, so I'm trying to print I value, and here we have a one method, something like sleep method. So this sleep method is expecting milliseconds. This particular sleep method is expecting milliseconds as a parameter. Now what I'm doing is, I'm providing the milliseconds. So later what we need to do here, I need to handle with a catch block here. So if I'm not handling this catch block, so we are getting an error, the line number 15. So now you can see, so finally to complete this particular try statement here, so which is not expecting the catch block, but it is expecting the finally statement here. Now what I will do, so I'm going to write the catch block. So interrupted exception ex and ex dot print stack trace basically. So this will give you the, whenever we get any exception, it will provide the name of the exception and from where to where it is called here. Now I'm trying to run this example. So see the outputs here, which is going to take some time here. I value 0, I value 1, I value 2, and I value 3, and I value 4, and so 4. Okay. So up to the 4, 0 to 4, it's become 5. Now what I will do, so we are having some space, like some time is taking here. Whenever we are trying to print the each I value internally, it is trying to take the some time here. Why it is taking the time here? Now you can see, so 1 is taken the some time. Now it is printing 2. Now it is printing 3. Now finally it is printing 4. Finally, it is printing the 4. Getting the one. So why it is taking? Here, whatever the current thread we are having, the current thread we are trying to sleep here. Getting the point? So we are making basically, so basically what happens internally, this is the simple diagram we'll have here. So the thread is started here. Okay. So it's trying to ready the thread here. The thread is initially it is ready. We'll discuss about the status about this particular thread. But what we need to understand here, from ready to what happens internally, it is trying to move on to the running here. It is move on to the running. Now, while running here, what we are doing here? We are trying to sleep. Sleep is nothing but waiting. We are waiting our thread. How we are waiting the thread here? With help of this particular sleep method. From at what time, like how many millisecond this particular thread is going to wait here? So around here, 2000. Around 2000 milliseconds here. Getting the point. This is important here. Around this particular 2000 millisecond, this particular thread is going to wait here. This thread is going to wait. So once this particular thread is waited, what happens internally? From waiting state to again, it will move on to the running state here. Getting the point. This is important here. From waiting state to it will move on to this particular running state. So the current example. So whenever it is printing the zero value, it is moving into the waiting state. From the waiting state, if the time is completed, it's coming back to the running state here. Okay. Again, it is moving into the waiting state. Again, it is coming to the running state. Getting the point. So until this particular condition will satisfy. Until this particular condition will fail, what happening internally? It is trying to move on to the internally waiting state and is coming back to the running state here. Okay, this is important. We need to understand here. So whatever the running thread we are having, we are making to wait some time here. Once the certain time is completed, now what we are doing internally, we are trying to run the current thread here. Okay, so this is a way we can stop certain time and we can execute once the time is completed here. Any questions? Any questions regarding this particular current thread information here?
Sir, I have one question.
Okay.
In the statement number 6, are we creating a new thread like a current thread, sir?
See, this is important here. Basically, we are calling the static method. The static method internally, it is returning the thread object. We are not creating anything here.
Okay. So how to create a thread, sir? Is it normal like thread t is some variable equal to new thread? Is it the same, sir?
Yes, begin here. Thread is a normal class only. So this is, you can see, so public class thread. It is not any abstract class. It is not having any other functionality. So this is the simple class here. How we created the normal classes. Same way, the thread class also we have. We can go for the same like what we created object. But here, what we need to think, whether can we use constructors or not, that is important. How many constructors we are having this particular thread class, whether all the constructors are having public access or not, that is important. If we are not having the public access, we cannot create an object. But for this particular thread class, we are having all are having public access only. Now you can see where we are having the constructors here. So you can see this is the one private constructor we are having, so which is expecting these many parameters. Okay, so this constructor we cannot call, and so this is the clone method. Now you can see this is the default constructor. So it is having public access only. So happily we can call this particular default constructor to create an object. So if you are not familiar with this default constructor, we have a overloaded constructor. Getting the point. This particular thread class is come with a multiple constructor. So now you can observe here. First one is the default constructor. Second one is expecting runnable as a parameter. So third constructor is expecting target as well as access control concept. But what we need to understand here, this is having the public access modifier, and this particular constructor is not having any access modifier here. Okay, so this is important. This particular constructor we cannot call from wherever we are trying to create an object here. because this constructor will available to call information within the same package. So wherever this particular thread class is having the name of the package, we can access. So that we already discussed in the previous example, whenever we are trying to understand the access modifier. So the particular constructor we cannot call, but this constructor we can call because it is having public access modifier. So this is a way we need to check the constructors. Now you can see, so this is the one more constructor. So we are having so different constructor in our like a thread class here. So some of the constructor they are having private, and some of the constructor they are having like a default access modifier, and some of them are having public access modifier. Now what we need to understand here. So by seeing this particular thread class, we can easily understand so which constructor is suitable whenever we are trying to create an object here. Okay. So I will explain the way of creating a constructor like a thread class object here. But we can create an object here. And instead of creating this particular object, now what I'm doing it, so calling this particular current thread method. So currently I'm getting what is the current thread is trying to execute here. This is the one way of execution. Okay, now what I will do, I will try to create a custom thread here. So to create this particular thread, so as I explained earlier, we have two options. Either we can implement the runnable interface, or we can go for the extending the thread class here. So first we'll extend, we'll implement the runnable interface, and later we'll extend this particular thread class here. We'll extend this particular thread class. Okay, now we'll understand the simple example implementing this particular runnable interface. So let's say here I'm going to create a class here. So it's contain the subclass here, something like new thread, and this particular new thread is going to implement from the runnable interface. And whenever it is implementing, now if I'm going to expand this particular interface, so you can see public interface runnable, and here we are having only one method. So now you can see it cannot contain any other methods, only one method, public abstract void run method. Getting the point? So this run method we are going to override inside this particular new thread here. Okay, so let me unimplement this particular method. So this is a way of implementing this particular run method. Okay, that we already identified in the previous example. So what I'm trying to provide the information, and here I'm going to create a constructor. And this particular constructor internally will create an object here. T is equals to new thread, and here I'm going to pass and something like demo thread. So how many parameters I'm passing basically? Here I'm passing two parameters. The first parameter I'm passing current object. So what is the current object? Basically it is a new thread. But if we observe, the thread class constructor is not going to take first parameter as a new thread, but the first parameter is going to take as a runnable here. The first parameter is going to take as a runnable. Now you can see if I'm going to call the name of the constructor. So you can see he's expecting runnable as a first parameter. Second parameter is expecting as a string name here. He's expecting as a name. Name is contained internally the name of the thread. But what I'm doing is the first parameter, I'm passing interface references. But how we are passing this particular interface references? How we are passing? With help of this particular the subclass here, because subclass is also internally it's contain the reference of the runnable interface, because we are trying to implementing this. Whenever we are implementing this particular runnable interface, so the new thread internally it's going to be the runnable interface only. Okay, so because of that I'm passing here this keyword. Now we understand here. So once we familiar with this, now what I will do here, I'm going to pass like a print the statement here. Now the message basically child thread. Okay, I'm trying to pass this particular child thread here. So once we print this particular child thread information, now what I'm doing is I'm going to start the thread. So this is important. We need to start the thread here. So once we create this particular thread here, we need to start. So if I'm not calling this particular start method, internally, it is not going to start the thread. Internally, it is not going to start this particular thread. So whenever the particular thread is started, whenever the particular thread is started here, it is going to call this particular run method. Okay. So finally, what I'm doing is, whatever we implemented this, I'm going to paste inside this run method. Inside this particular run method. Okay. So this is important, we need to understand here. So finally, here what we need to understand here, I value. After this particular I value, now, okay, along with after I value, before only I will print this. Before only I will print the name of the thread information. So which thread is trying to execute this particular run method? I'm trying to print this particular T information. So we can easily understand here which thread is trying to execute here. Okay. So this is, we understand here. And now this method, like this particular class, I want to create an object. Getting the point? This particular class, I want to create an object. So how I'm going to create an object? So here only I'm going to provide, the thread main here. Thread main, I'm going to come up with a one more class here, and I'm trying to generate the main method. So once I generate this particular main method, and internally what I'm doing here, whatever the logic we executed right now, the same logic I'm going to provide here. The same logic I'm going to provide. And here, new thread. Okay, simply I'm creating an object. Whenever I'm trying to create an object here, what happens internally? The child thread is going to create, and the child thread, it will try to call the run method, and it internally, it will execute the whatever the loop statement we defined here. Now observe carefully. So this is the child thread information we are printing here. Okay. So observe carefully. Observe carefully. So where I define this particular child thread here. Where I define this particular child thread. Now I'm going to provide the information about this particular new thread. So observe. Here I'm trying to print the child thread, and T I'm printing. Getting the point? T I'm printing, because this is the reference of this particular thread class. So whenever we are providing this particular reference of this particular thread class, what happening internally, it will call the toString method. So just now we discussed about this particular toString method. But what we need to understand here, what is the name of the thread we provided? Something like demo thread. So now you can see each time how many times it is printing this internally. So it is trying to come up with the name of the thread, priority, and thread group name. And now you can see these are all the I values. So which thread is executed here? This particular run method is executed by the which thread here? This is important here. Okay. So which thread is executing? Child thread. So demo thread, whatever the demo thread we provided, the demo thread internally, it is a child thread object here. It is internally child thread object. Getting the point? This is important, we need to understand here. This is important, we need to understand here. So whatever the code we write inside this particular run method, the run method code is executed by the whatever the newly created thread only. Okay. So now what I will do, I'm going to copy the same information here, and here I'm going to paste it. After this particular object creation, I'm going to provide the information. But right now, here we don't have this particular T. So what I will do, thread dot current thread. Okay, the current thread will provide so whatever the thread is executing, this particular line number 9 statement. whatever the thread is executing the line number 9 statement, we are going to provide the information. So carefully observe, this example will give you the multiple results here. This example will give you the multiple results. Now observe carefully. So we cannot understand what happening here. So we are trying to get multiple values. Okay. Now we'll see here by one. So we will understand here how this particular child thread as well as main thread is executing. Now you can see this is the child thread. This is the child thread. Okay. And this is the main thread. So see the differences here. Demo thread. Demo thread basically it is a child thread. And main, whatever the main we provided, this is the main thread. Main thread is executed by this particular code. Main thread is executed by this particular code. And child thread is executed by this particular code. Getting the point? This is very important here. Now you can see the object we created, and main thread is called the I value 0, and demo thread is called the I value 0, and main thread is called the I value 1, and demo thread. So main thread and demo thread, main thread, demo thread, and so if you see demo thread here, it's coming as a twice here. Is coming as a twice, and finally this is the main thread. So for example, if I'm going to run one more time, we are going to get different output here. Here we are going to get different output here. So we cannot imagine whatever the output we get earlier, so it's not going to match with the same. Now you can see, so this is the object creation, and the main thread is called the loop value, and later you can see demo thread is called the 2 times, and the main thread is called the 2 times, and again demo thread is called 2 times, and the main thread is called 2 times. Okay, finally demo thread. So now the current output, so each time we are getting 2 times here. If I'm going to run one more time, so we may get the different output here. Okay, because here what I want to provide the information, so it is a separate path of execution. It is not going to depend on the another thread. Right now how many threads we are having? 2 threads. First thread is a main thread, and another one is a child thread here. Okay, the 2 threads, they are having separate path of execution here. This particular through whatever the 2 threads we are creating, it cannot contain each other. So it will try to execute this own path, and this particular thread is going to execute own path here. Because of that, so every time we'll get the different outputs here, but output is same. The order of printing the message is different here. Okay, so any questions here? Any questions regarding this particular new thread which we implemented from the runnable interface?
Sir, I have one question. So this priority is 5. So every time when we will use the thread, so priority or every time it will be 5?
So basically we have a priority that we can set here. For example, if I'm going to set the priority, you can see t dot thread we are creating here. After this, t dot set priority. Okay, you can provide the priority. For example, if I'm going to provide 12, now what happens here? I'm going to run the same example. Now you are getting an exception here. So why we are getting an exception here? So you can see whenever we are calling this particular set priority, we are getting an illegal argument exception. Illegal argument exception. Now what I will do, I will move on to this priority. We'll see what is the restriction we are having here. How many values we can provide here? Oh, I thought they provided here. Okay, so they did not provide the range here. Basically, range here we should give 0 to 10. 0 to 10. If I'm going to give as a 10, getting the point. And again, I'm trying to run the same example. Now, what you understand here? Whatever the thread we provided here, the thread is having priority as a 10. Now you can see 10 we are having, and the main thread by default it is a 5. Now I modified our child thread priority to 10 here. Getting the point. So this is the way we can change the priority. So basically, priority what it will do. So which one is going to have the highest priority? It will take the high priority here. So once the high priority threads are completed, it will move on to the low priority executions here. Okay. So this is going to like schedule by our thread scheduler. So explicitly, we are not going to do anything. Just you can specify the priority of this particular thread here, and internally the basically thread scheduler is going to take care of calling the priority threads here. Okay. So this is a way of we can modify the thread priorities. So any other questions?
Sir, I think the priority is from 1 to 10, sir. Is 0 allowed, sir? Can we try?
Let's see. Yes, correct. So 1 to 10. Okay. So any other questions? Okay. So here, what is the minimum priority, maximum priority? Okay. See. So maximum priority they are provided as a 10. Num priority by default is a 5. So here only we are having. So minimum priority is 1. Okay. So here they provided the information. So we did not check this information. So now you can see minimum priority is 1, normal priority is 5, and the maximum priority is 10. So between these three only we are going to check the condition. For example, if I'm going to open one more time, now you can see whatever the new priority we are providing, if it is greater than this particular max priority, we are getting an exception. What is an exception? We are getting a illegal augment exception. Right now, we are getting same exception. Getting the point. So here only we are having the condition. And now you can see this particular new priority, if it is less than to this particular minimum priority, again we are going to get an exception. Okay, so I did not check this particular condition. So what is the minimum and maximum? And whatever the message we are calling here, now what happening internally? This is the max priority and the min priority we are checking here. This is important here. Okay. So this is the way we can change the priority information. Now what I will do, so right now we identify the simple example on this using the interfaces here. Now what I will do, I'm going to create a thread by extending this particular thread class here. So this is the another approach to create a thread here. Getting the point. This is important here. So let's run the one more example by extending this particular thread class. So what is the name of the thread we can provide? Something like extend thread. Okay, this particular thread is trying to extend from the. So now what you need to understand here, this particular thread is extend from the thread class here, and so you can override the run method basically. You can override this run method. So if you're not override here, what happens internally? It will call the thread class run method. But I don't want to call the thread class run method. Here we are trying to provide the specific implementation. So whenever we want to provide the specific implementation, what we can do, we need to override our whatever the run method we are having in the super class, so that we will get to know the specific implementation here. Okay, so run method I'm trying to override, and here I'm trying to create a constructor extends thread here. Getting the point. And here what I will do, so because simply we can call the super. So here we don't need to create any object. Why we don't need to create any object? Because internally the thread will create an object here. Internally the thread we are creating. So whenever we are creating this particular extend thread object here, what happens internally? It will first create the superclass object, and later it will try to create the child class object here. So this functionality we already identified in the previous example. So why I'm calling this particular super? I want to override the thread name here. So this is basically child thread. Now what we can do? So if we want to print this particular child thread information, now what is the best way of printing this? So something like child thread here. So I'm going to use current thread object here. Current thread object here, and I'm going to call the start method here. Whenever we are going to call this particular start method, so that we already identified, it will try to call this particular run method. Now let me copy the same code. Whatever the code we are having, I'm going to copy the same. Okay, so here we don't have a key. Here we are not having key. Now what we can do basically, so I want to print this information which thread is trying to execute here. So you can call this object. You can call this object. So it will try to print this particular current object. The current object internally, it is contain thread information. Okay, so this is, we need to understand regarding this particular extended thread here. And later what I will do, I'm going to use the same main thread. Let me go to this. Instead of this particular new thread, I'm trying to call the extend thread. So remaining everything is same. Remaining everything is same. Now you can see, so child thread and main thread, child thread, main thread, child thread and main thread. So whatever the output we are expecting it, we are expecting here. Getting the point? So from like using this particular runnable interface, same output we are getting, and from this particular extend class also we are getting same output here. So which approach is the best one? Any idea? Because we already discussed about this particular inheritance concepts here. So if you are familiar with the inheritance concepts here, we can easily understand here which one is the best approach here. Okay, so basically, whenever we are trying to extending here this particular thread class, here we cannot extend the more than one class here. Okay, so you are going to lose the concept to call extending one more class here. Getting the point? And implementing this particular runnable interface, only one method functionality will get it here. That is called run method. But using this particular thread class, we are going to get some additional methods. Getting the point? The name of the thread, priority information. So we have some additional method we are having inside the thread class. Those method we can access here. Those methods we can access here. So this is important things we need to understand here. So which approach is the best one? So that we need to think. If you are not interested with the additional methods, whatever the additional method we are having inside this particular thread class, if you are not going to use those additional method, so directly we can implement from this particular runnable interface. Or you need some additional methods as well in our current example, wherever to modify something, to update some values here. Okay, so in that case what we can do, we can extend this particular thread class here. So this is the approaches we need to follow. So either whenever we are trying to implement this runnable interface, or whenever we are trying to extend this particular thread class here. Okay, this is very important here. Now what I will do, I'm going to create a multiple thread classes here. I want to create a multiple threads here. So which one is the best approach to create this particular multiple threads here? So now what I'm doing here, I'm going to use the same this particular extends thread here, and here what I will do, I'm going to private string name here. Okay, and this particular thread is extending, like is expecting one parameter that is called name here. And instead of calling this particular super, now what I will do, I'm going to pass as a name. And after this dot name is equals to name here. Okay, and instead of this particular this, now I'm going to modify the name here. So here we are going to print only name of the thread. And whenever we are trying to creating this extended thread here, how many objects we can pass here? First one I'm providing as a 1, so 2 and 3. Okay, so these many threads. So right now we are having 3 here. So we are having 3 threads here. And now you can see if I'm going to run same example, we'll observe multiple threads this example is going to run. Multiple example, like multiple threads, whatever the object we created here, now you can see these many times the threads are executed. So here what we need to understand here, so these are all the child threads we created, 1, 2 and 3. How many threads we created here? 3 threads. So each thread internally it will call the run method. So one thing, like first thread is calling the I value, so second thread also it's calling, and at the same time the main thread is trying to execute this, and third one. And now you can see second thread, third one and first thread. So main thread is printing, and later first and second, third main thread. Okay, so first, third and second, and later main thread. Getting the point. And finally these are all the 3 threads we are executing here. The last one main thread is executed. So this is a way we can create a multiple threads here, where whenever we are creating the multiple child threads, getting the point. Internally, what happening internally? So each thread is executing separate path here. Each thread executing separate path here. Okay. So this is we need to understand very carefully. So this is the way of creating multiple threads here. Any questions here?
Sir, I would like to understand the difference between this extend and implement, sir. Can you please tell once again? Just a brief, not in detail.
So it is important. See, basically, if I want to go to the thread class, so this particular thread class, see, you can see the one method set priority. This set priority we cannot have inside this particular runnable interface.
Okay. Yeah, it has only run method, right? Okay.
Yes. So the like this, we have some additional methods. So those we are having inside this particular thread class, but so those information we cannot get it from the runnable interface. But even I want to go for the default information. So what you can do, we can go for this particular runnable interface directly. You can implement this particular runnable interface, and you can create the threads. So what happens other time, basically along with the thread, I want to have some methods information, because I'm going to modify the default configurations basically. Like it's like a name of the threads, priority, whether this particular thread is in the live status or it is in the terminated status. So those information we can get from the thread class, because the thread class can contain some additional methods here.
So if you want to get additional methods, if you want to access the additional methods, then we need to extend the thread. If we don't want any additional things, then we need to go for the runnable. Am I right, sir?
Yes.
Okay.
Okay. Now, so I'm going to provide the one of the important concept here. So using this particular isLive method as well as join method, what we can understand here, because these two methods are coming from the thread class, we can easily understand whether the thread is in the live status or it is in the terminated status. Okay. So first we'll see isLive method. IsLive method it will try to return the boolean value. So for example, I'm going to show that particular method is live. Now you can see this is the name of the method I'm talking about, and it is a native method. So we'll discuss about this particular native information, how this the configuration, like how this implemented internally. Okay. Now what you need to understand, I'm going to call this particular method to check whether this particular thread is in the live status or it is in the terminated status. Okay, how this is going to provide. If the thread is in the live status, it will return the true. Otherwise, it will return the false here. Now, what I'm doing here I'm going to print this particular, where it is, thread main. Here I'm going to return object information. So it's nothing but thread 1 I can create. So here thread 2 and thread 3. So how many objects we are having? 3 objects here. Getting the point. So and using this particular 3 object here, now what I'm doing here. So I'm trying to checking the condition. Where I'm checking the condition? So here only I'm trying to checking the condition. Thread 1 so is live. Okay. Now what we need to understand here, thread 1 dot is a live method. So we have a 3 objects. Second one is 2 and third one is 3. And here so second and third. So whenever we are calling this, now you can see what happening internally. It is printing 3. So if you observe carefully, so once it is completed the execution, now you can see here the 3 methods. The each thread internally it is printing true. Getting the point? This is important here because the threads are in the still live status. So when it is going to terminate it here, for example, after this particular try and catch here, if I'm going to print this, now after the execution of all here, now what you need to understand here, now you can see what happening internally. It is returning false here. So first one is returning true, second one, third and returning false here. So if you give some time here, the particular 3 threads will become false, or if I'm going to run one more time, what happens internally? Again, so any one of the method will become true because we don't know, they're not going to depends on the each other. So because they are going to have separate path of execution here. Getting the point? So this is important, we need to understand here. But once the operation is completed, all the threads will become terminated. Now you can see, so earlier 2 threads are in the terminated status, but right now only 1 thread. So still this particular 2 threads are in the active here. Getting the point? But what we need to understand here, using this particular is allow method, we can easily understand whether the thread is in the active status or in the terminated status here. If it is returning true, we can easily understand here it is in the active status. Or if it is returning false here, what we can understand, it is returning like it is in the terminated status here. Okay. So this is a way of identifying the thread information here. And so tomorrow we'll continue join method. So once we familiar with the join method, we'll move on to the thread priorities, and later we'll move on to the synchronization. So once we familiar with this particular synchronization here, now what we will do, how the interthread is going to communicate each other, like using the notify all method. And once we completed this particular notify and notify all, we'll find out the deadlock situation. So these are all about the thread information here. Okay. So most probably tomorrow and after tomorrow, we'll try to close up our multi-threading concepts here. So any questions regarding our today's session? Okay. So if we don't have anything, we'll continue tomorrow. So tomorrow also we have a session. We are going to continue.
Oh, sir, tomorrow Saturday we have session.
Yes. So because we did not connect the last 3 days, so I'm going to take the session tomorrow as well.
Okay.
Okay, sir. Thank you.
Thank you.
Thank you.